The title of today's lesson is Circles, Area and Perimeter. So get that down in your red book. So circles, area and perimeter. So, you might already know this. I think we have done this before, but the first thing we're going to deal with is a circle, and we're going to talk about some things and some parts of a circle that we need to know. I can, yeah. I'll try my best. Just message, and I'll try and slow down if I need to. Okay. So this is a circle. So make sure you draw the circle. So from the center to the edge of a circle, this is called a radius. So draw this down. This here is called a radius. If I go all the way across there like so, this here is called the diameter. And we can see that because the radius is 2 diameters, the diameter is twice as big as the radius. Might be worth writing that. So we've got diameter and radius. Now, if I highlight this part here, this highlighted part here, so if I go from the radius there, this highlighted part is actually called a sector. So it's like a part of the circle. And you can also have, we don't need to know this one right now, we won't use this one today, but it's worth noting on the notes that if I've got a line which touches a circle, this is called a tangent. T-A-N-G-E-N-T. So, the area of a circle, you use a special symbol. Now, I think you know this already, but I'm going to write it down anyway. So, it's pi. Now, pi is a special number. It is an actual number. And it's the proportion of the circumference to the radius or diameter. So in this case, if I type down pi in here, now you get pi on your calculator. Now pi is above, you can see that, the times 10 to the x, which is like the bottom middle. And the way you do that is you press shift and pi on your calculator. You will need your calculator today. Shift pi, press equals. If you press equals, it just comes up with pi, but if you press the S to D button, it comes up with 3.141592654, and this continues on forever. You only really need to know pi up to about 1 or 2 or 3 really. But the formula for the area of a circle is pi times the radius squared. That's really important. And the circumference is equal to pi times by the diameter. Well, don't forget the diameter is 2 times the size of the radius. So you could also say that it's 2 times by pi times by the radius. Both of those are valid because we know that diameter is double the radius. So get both of those down. I'll give you a second to get those down. All right. So let's have a go at some of these then. Now I've got 2 here. I'm going to do both of these examples. This is example 1 and example 2. I'm going to do both of these. I'm going to give you a second to have a go. So I think it's always worth, with these, always writing down with any circle question, whether it's a circle or whether it's a cylinder or whether it's a sphere or whether it's a cone, it's always worth writing down what the diameter and what the radius is straight away. So you'll notice in this first example, the 12 is from the center to the edge. So my radius in this case is equal to 12. But my diameter in this one is going to be equal to double that, which is equal to 24. So always write those down just to get you started. And this is asking for the area of the circle. So I write down what the formula for the area of a circle is. So my area is equal to pi times by my radius squared. So I don't need to actually know the diameter. So really nice and easy. Area is equal to pi times by, in this case, its radius, which is 12 squared. So to get the pi up, remember, I need to press the shift. It's like a yellowy kind of thing above the times 10 to the x. So I press shift pi times by 12. Now your squared button looks like this. So in fact, let's make a little note of that. So your pi button it's this key here that you need to be above. Okay, and you've got to press. Oops. You've got to press shift first, which is in the top left. And then you press that button, okay? If you want the squared button, so that's that's how to get pi. To get the squared button, you need to use the x squared key, which is that one. Okay? Maybe I shouldn't have put the things around them. I'll highlight them instead. Better. There you go. So, yeah, it's going to be shift pi times by 12 squared. So my area in this case is equal to, well, now it's coming to it gives you in two parts. It is, yeah. So it gives you it, if I put this in, it gives you as 144 pi. You do need to know it like that, because this, you need to write it this way on a non-calculator paper. Okay? But if this one here is asking it for to 1 decimal place, and to do that, you press the S to D button, which looks like this, and that gives you your area, which is 452.4, and in this case it's millimeters squared. So that's the answer to your first one. For the one on the right hand side, it's a little bit different here, and the reason that it's a little bit different is because they're giving you the diameter first. So actually I know my diameter is equal to 3 meters. Again, it's asking you for the area of the circle again. So my radius is equal to 1.5 meters. 5 squared, there it is. And if I press equals on that, so my area is equal to, this one here is a little bit smaller, isn't it? To 1 decimal place, it's going to be, well, it's 7.068. So I need to round that to 1 decimal place, and that's going to be equal to 7.1 meters squared in this case, because it's area. So get both of those examples down. Get both of those examples down. So example 1 and example 2. I'm going to give you a second to have a go at a couple of these yourself in a second. Okay, put your hand up if you got all those down. Put your hand up if you got it down. I'm going to give you another second or so, and then I'm going to move on. Brilliant. Okay, so have a go at these to yourself. They're quite simple, very simple to the ones at the top. You can have a go at them on your whiteboard if you want, or you can have a go at them in your blue book. Have a go at those to yourself. Okay, have a go at these to yourself. You should be able to fly through these. If you've got the answers, you can pop them in there. Well done, those of you who already got it. Brilliant. What does it say in the notes to round to? It says here, doesn't it, 1 decimal place. Brilliant. Brilliant, brilliant. Okay, so I'm going to start going through both of these. So the first one here, always write down what your radius and diameter is. My radius is equal to 3 millimeters. My diameter would be double that, which is 6 millimeters. So my area is equal to pi times by my radius squared, which in this case is equal to pi times by 3 squared, which would be 9 pi, which is 28.3 millimeters squared. Brilliant. For this one here, my diameter is equal to 4 meters this time. My radius is going to be half that, isn't it? Which is 2 meters. So you've got to make sure you're checking that. So my area is equal to pi times by 2 squared, not the 4, which is going to be equal to 4 pi. So 4 shift pi, which is equal to 12.6 it is. 12.6, brilliant. Okay, so 12.6, 28.3, brilliant. So let's have a look at this one here now. Now this one here isn't that much trickier. We'll have a go at this one on the left. This one here is example 3. So get that one down on the left. It's not that much harder. Now this here is a semicircle. And a semicircle is when they cut a circle in half. So if we know that we're cutting a circle in half, we're halving what that area is. Now the important part is to know that this here, this 2, represents the diameter. So my diameter is equal to 2 meters, in which case my radius is equal to 1 meter. So when I do this one, my area of a full circle is equal to pi times by my radius squared, which is pi times by 1 squared in this case, which to 1 decimal place, I'll do 2 decimal places because I'm not finished yet, is 3.14 centimeters squared. But the problem with that is that's for a full circle, isn't it? We don't want a full circle. What we want is the semicircle. And the semicircle is going to be half of that. So it's going to be equal to 3.14 divided by 2. Let's write that down. 3.14 divided by 2, which is equal to 1.57 centimeters squared. Brilliant. So get that one down on the left, and once you've done that, have a go at the one on the right. Again, it's quite straightforward. Anybody got it?
So, you're going a bit too fast.
Okay, let's have a go at it then. So we know that the diameter is equal to 8 millimeters. So the radius is going to be half of that, which is 4 millimeters. Area is equal to pi times by the radius squared. In this case, its area is equal to pi times by 4 squared, which is equal to 16 pi. But that's for a full circle. And actually, I want a semicircle. So the semicircle area is 16 pi divided by 2. 16 pi divided by 2, which is equal to 8 pi centimeters squared. But remember, they want it to 1 decimal place here. So that you'd leave it like this if we were on the non-calculator. However, I want it to 1 decimal place, so 8 shift pi to 1 decimal place would be 25.1. Brilliant. Super. Really good. Well done to all those who got it. Brilliant. Very impressive. Okay, so we've done those. Let's have a look at this now. Now, this isn't that much harder. Who can spot what the difference with this one here is? Yeah, that's exactly it, yeah. So what we're looking at here is we're looking for the circumference here. The circumference of the circle. That's what we're looking for. We're looking for the circumference of the circle. Now, the formula for the circumference of the circle, go all the way back up to the top. Go back to your notes. We did do this. We've done the area. Circumference of the circle is pi times by d, or 2 times pi times r. So let's go back down to this one here. You'd start off in exactly the same way. So in this case, I know that my radius is equal to, get this one down as example 5, I think it is. So my radius in this one is 3 centimeters. In which case my diameter here is going to be equal to double that, which is 6 centimeters. And your circumference is equal to pi times by d, which is diameter. So C is equal to pi times by 6. And pi times by 6 is equal to 6 pi centimeters this time. Why is it that my units are centimeters on this and not centimeters squared? Great question. Why are my units?
Because when it's centimeters squared,
That's exactly it. Yeah. So
Radius.
the area is centimeters squared, but when we're looking at this, the circumference is the distance around the outside here. Okay, so the circumference is the distance around the outside. Now they're asking it to 1 decimal place again, so let's type that in. So shift 6 pi is equal to, and that's equal to 18.8. It was 18.849555 carrying on, so I'm rounding after there. Now, why have I made a little mistake here with this example on the right hand side? Why have I made a little mistake? It's not a mistake. They're definitely different questions, but what's my mistake?
It's the same.
Yeah, it is. Yeah, that's exactly it. So, although they look different, because this one here says the radius is 3 and this one here says the diameter is 6, actually these questions are exactly the same because the diameter is equal to 6 centimeters and the radius is half of that, which is 3. So although they look different, they're actually exactly the same. Has everybody got that one? Put your hand up if you've got that one down on the left-hand side.
I do.
Brilliant, brilliant, brilliant. All right. Now, this is the one that I wanted to really focus on. There is another one down here, which is a little bit trickier, which is this one here. We'll talk about those in a second. We will come back to those. But this is the one that I wanted to focus on here. So this one here is example 6. Now, this is how I think they are more likely to come up, okay? So this one here is example 6. Get that one down. You can draw it if you want. You can draw it. But this time it's saying that the area is equal to 19 meters squared. The area is equal to 19 meters squared. It's actually asking now to work backwards and find out what the radius is. This is what we're trying to find. You can draw that if you want. Ooh, that looks like it says the radius is equal to the area. Let's delete that part. Now, we did a little bit of this when we were looking at we did a little bit of this when we were looking at quadrilaterals and triangles working backwards, and we said that the key to this is to do 3 things. Now, the first thing you need to do always with this, so write these down in your notes, is to write down your formula. Okay, you write down your formula. Number 2 is you sub in the values you know. So you sub in the values you know. The third part is to simplify. And then the last part is to solve working backwards. We did that yesterday when we were looking at the quadrilaterals and we were looking at the triangles. Okay, this here is really important for those trickier questions which come up, which will give you more marks. They're the 4 steps. You write down the formula, then you sub in the values that you know, then you simplify, and then you solve working backwards. Let's just bring this down so we've got it in here. So we write down the formula. There's the question. We write down the formula. We sub in the values that you know. You simplify, and then you solve working backwards. So the first thing I need to do is to write down the formula. Now, what do I know? Do I know the area or do I know the circumference? Well, it's telling me the area. So what is the formula for the area of a circle? Well, the area of a circle is equal to pi times by the radius squared. So that's part one. Part two is you sub in the values that you know. Now the value that I know is this part here, which is that 19 meters squared, which is the area. So I'm not subbing that in for R, I'm subbing that in for the area. So it's going to be 19 is equal to pi R squared. Now you simplify, we don't actually need to simplify with this one, because I've already got pi and R. But remember, solve, we've done this loads with the algebra, means to find out what our unknown is. And our unknown in this one, the thing that we're trying to work out is R. So the things I need to get rid of are going to be this pi. Yeah.
You know, for
When you after you the 19,
Yeah.
is it meant to be a times in between the pi and the r squared?
You can put a times, but don't forget, with algebra,
it's
if you had
to
A
that,
times B, it'd just be AB. So the pi times R, this is the kind of the simplified part, isn't it? So pi times by R squared is the same pi R.
Yeah,
Does that make sense?
Yeah.
Okay, so what we're doing now is we've got the pi, which we need to get rid of the pi, and we also need to get rid of that squared. But you've got to do it in a particular order. And you have to get rid of the pi before you get rid of the squared. And that's because you need to get rid of the times before you get rid of the indices. And if you were doing it forwards, you'd square it first and then times by pi. So if we're going backwards, we get rid of the pi by dividing by pi and then square root it. But we'll talk about that in a second. So the first thing I need to do is to get rid of the pi by dividing both sides by pi. And this is where it gets a little bit tricky. If I divide the right-hand side by pi, I'm just left with r squared. But in your calculator, we need to divide the left-hand side by pi, which is going to be 19 divided by shift pi. 19 divided by shift pi and 19 divided by pi is 6.04. And then the last little part,
Do you square root it?
we need to get rid of that squared by square rooting both sides and square rooting both sides. So it's going to be, now if it was me, I'm going to do square root of the answer. So the 6.04, you could put 6.04 in. Remember the square root button is the one which is to the left of the squared button. So it looks like this. That's what it looks like. So I'm doing the square root of 6.04. The square root of 6.04 is equal to r. And that's equal to well, the answer here is 2.5. No, it's not. 2.4576411, carrying on like so. So to round that to one decimal place, we need to put a line after the 4. The 5 means I'm going to round up. So that's going to be r is equal to 2.5 meters in this case. Because my area is meters squared. So get that down in your notes. Once you've done that, have a go at the one on the right hand side. Some people are getting the answer now. Good work, good work. Let's see if anybody else gets it. So I'm going to start going through this. I think some people might have rounded wrong. We'll see how it gets on. So here I already know the area of this. So the area circle, write down the formula. Area is equal to pi times by r squared. Sub in everything you know. In this case it's the area, which is 136. So 136 is equal to pi times by r squared. We need to get rid of that pi by dividing both sides by pi, dividing by pi. So 136 divided by shift pi is equal to 43 well, let's write it, I'll do it to 2 decimal places. 43.29 is equal to r squared. And then the next little part is we need to square root both sides, don't we? Square root, square root. So it's the square root of here, which is 43.92, which is equal to 6.579513, continuing, but remember we only need it to 1 decimal place. So I put my line after here. I'm looking at this one here. It does round up. So it's r is equal to 6.6 millimeters. Well done, those who got it. Well done, those who got it. Brilliant, brilliant. Very impressive, this is. Super. So this one here is a little bit different. We're still working backwards here. What is different about this one here?
Circumference.
Yeah, it's giving us the circumference, isn't it? So here, the circle has a circumference of this. Okay? And we know the formula for circumference is equal to pi times by d. So my circumference is equal to pi times by d. Write down the formula. This one here is example 7, is it? I'll give you a second to copy it down, actually. So yeah, it's giving us the circumference now. So I write the formula down. I sub in what I know. In this case, I know that the circumference, so the distance around that circle, is equal to 89, is equal to pi times by d. So to find out what d is, I need to get rid of that pi by dividing both sides by pi. So divide by pi, divide by pi. So it's going to be 89 divided by pi, which in this case is 28 28.3 is equal to the diameter. Let's do 3.2. I'll do it to 2 decimal places. Now, why have I not finished there? Why have I not finished there? What you're asking for?
To find the radius.
Yeah, and so how do I find the radius of this one? If I know what the diameter is,
You divide by 2.
you need to divide by 2, yeah. So I take this here, probably shouldn't highlight that actually. And to find my radius here, I need to divide that answer by 2 at the end, which is equal to, well, the full answer is 14.164789, continuing. So to 1 decimal place, I put my line here. This means I'm rounding up, so it's going to be equal to, the radius is equal to 14.2. Brilliant. So get that one down as example 7, and then have a go at that one on the right hand side. Now I can see a common mistake here on the people who are doing it, and I'm going to show you what that common mistake is. So it tells us the circumference here. Okay, my circumference, I know the formula for a circumference is equal to pi times by d. I sub in what I know, so it's 113 is equal to pi d. I get rid of my d by dividing, get rid of the pi by dividing both sides by pi. So I end up with 113 divided by pi, which is equal to 35.969, continuing, is equal to d. To find my radius, I divide by 2. So divide by 2, and this gives us, my radius is equal to 17.9845, continuing on. So if I round up, I put my line there, I'm then going to round up, you're right. However, when you round up, it is 18, but because they want it to 1 decimal place, the 9 is going to send everything else up. You need to write it like 18.0 is equal to the radius. 18.0 is equal to the radius. Okay, if you are catching up at home, I'm going to show you the next few questions. So there's a question there. If you're catching up at home, have a go at that one. Pause now and have a go at that if you're catching up at home later. And there's your answer for that. If you're catching up at home, pause and have a little go at that one. And here's a worksheet if you're catching up at home later. So have a go at that if you're catching up at home. And there's some further worksheets if you're catching up at home. And there's your answers if you're catching up at home.